Hey everybody, Dr. A here, and in this video we're going to be exploring an example of tributary loading. So let's go ahead and get started. In the given information, we're being asked to determine the force that column A supports. And then we're being told that all the columns support one floor with a surface load of 100 PSF. So this is a plan view. Okay, we'll make a note of this. This is a plan view. All right, now where is this 100 PSF? We got to visualize things first. The 100 PSF is going into the screen, okay? If this is a plan view, that means you're looking down on the slab, all right? So that 100 PSF shows up as like a little vector surface load going into the screen, all right? Now, those columns are going to be supporting different portions of that 100 PSF slab. So here's what I'm going to do. I'm going to write solution. Now, before I do any calculations here, I want to go ahead and visualize this. Remember, I've said this in some of my other videos on this topic. A big challenge with these kind of problems is really just the visualization. Okay, so to help me visualize this, I'm going to draw some 2D views of this system just so I can better visualize what is going on, all right? So this particular 2D view is going to look like this, all right? Now that 100 PSF is like this, 100 PSF. And again, this is a 2D view, right? This is a 2D view. So what are the dimension lines here? Well, these are the 15-foot dimension lines, 15 feet, 15 feet, okay? So this particular view would be like if I look in this direction, okay? So we can call this, you know, section maybe AA, okay? So this is section AA. All right, what if I wanted to look in this particular direction? Okay, what if I call this section, let's just call it BB, okay? What would that look like? Well, again, I would have that slab there, and I would have some columns. Like this. I encourage you to draw this out on your own along with me. Again, the tricky part about these kind of problems is not really the calculations, it's the visualization, okay? So there's 100 PSF. Now, what are the spacings of the columns in this particular direction if I'm looking at section BB? Well, this is the 10 feet and this is the 12 feet, okay? We'll call this, again, section BB. And so, again, that 100 PSF is spread out over this entire surface going into the screen when you're looking at the plan view. But then if you look at either of these side views or section views, what you see is 100 PSF, but you just see the side of it, okay? And so what we're interested in is how much load this column A is going to be supporting, okay? So the way you can think about this, that we often think about this when it comes to column tributary loadings, is a one-way system, okay? Now, there are some techniques you can use to treat this as a two-way system as well, but for the most part in practice, whenever you have column spacing and you are not really looking into any support beams in between the columns, you treat the column tributary area as a one-way system. And so how does that work? Well, if I'm gonna redraw this slab, okay, again, a lot of visualization here. We're redrawing a lot of things. I'm gonna redraw this slab. In fact, let me draw it a little bit better for us. Okay, redraw this slab, and I'm going to redraw the columns for us, again, for visualization purposes. There's that column. Okay, and this is column A, of course. So, and then what about the dimension lines? Don't want to forget about those. 15 feet, 15 feet, 10 feet, 12 feet. Okay, so what I'm going to do is I'm going to draw these dashed lines halfway in between the columns in this particular vertical direction, okay? So these are going to be 7.5 feet dimensions, okay? Draw that a little bit better. 7.5 feet, okay? Now, what about in the other direction? Well, again, I'm going to go halfway in between adjacent columns, okay? So if I go halfway in between adjacent columns, what is this dimension here? Well, that's 5 feet. And then what is this dimension here? 6 feet, all right? And so the way we're modeling this is that the tributary area for column A is this rectangle, all right? So I'm going to say A tributary for column A is going to be, again, this rectangle. So what we're saying is all the load, the portion of the 100 PSF that is within this rectangle is going to be transmitted and supported by column A. So what is that tributary area? Well, that's going to be 15 feet times what? Times 11 feet, okay? So it's this 7.5 plus 7.5 foot length. So this is 15 feet here, 7.5 plus 7.5 times 5 feet plus 6 feet, which is this 11 feet, okay? And so if you get that tributary area, that's, say, 15 times 11, that's 165 square feet, okay? Now, if you want the equivalent force that's being transmitted into this column from the portion of the 100 PSF trapped within this area, how do we do it? Well, I'm going to say P for, force. We use P for force. P sub A, so that's P, the force in column A, we're going to say is the force developed in column A from the portion of the 100 PSF within column A's tributary area, okay? So how do I calculate that? Well, I'm going to say the force in column A is 100 PSF multiplied by 165 feet squared, okay? And so what do I get? I get 16,500 pounds, or you could say 16.5 kips. Okay, so that is the force that column A will support due to that 100 PSF spread out over this entire slab, but the portion of it that column A has to support is trapped or bound within this tributary area. So let's make a couple of remarks here, okay? Remarks. For loading, let's say tributary loading, how about that? For trib loading for columns, what we do is we say the column force is computed as P column equals Q times A sub T of that particular column. All right. And again, we treat this as a one-way system, and we draw these little dash boundary lines halfway in between adjacent columns in each direction. So even though the problem didn't ask for this, I'm asking you all, could I get the loading in this corner column here? How would I get the force in that corner column? Well, I would say 100 PSF Q times the area, the tributary area for that corner column. Could I get that pretty easily? Yeah, that would be what, 5 feet? Because it's the other 5 feet from this 10 feet. It's this 5 feet times this 7.5 feet, okay? And so that would be how we would get the loading in this corner column. What if I wanted this edge column over here? Well, I would say Q, 100 PSF, multiplied by what? This tributary area, right? This tributary area, if I'm interested in this column over here, this right edge column. And how would I get that tributary area here? Well, I would say this 7.5 feet multiplied by this 11 feet. Okay, so you could get the equivalent loading in all of these columns if we wanted to. But again, this problem just looked for the loading in column A. Okay, so that's going to conclude this example. The answer is 16.5 kips. Thank you for watching. If you found this helpful, please hit like and subscribe and be on the lookout for other content like this.